Okay, um, I'm going to show off a little. It's funnier that way. Um, just yesterday, I completed work on this. It's actually been a sort of a work in progress for quite years. But it got to the point where I really needed to get this thing up to my standards for what I'm going to be doing. It's de-soldering tool, this part of it, a very small part of it really. This, of course, here's the iron solder puller. It's a pace, in my opinion, about the best deal going. They're not cheap, I know stretch, but they hold up well and they work. Given a good support system for these irons. They, of course, they make their own controllers for those things, and they're salty. They're expensive. And I had considered, I've seen them on eBay, kind of reasonable. I'm looking around, I have everything I need to build my own controller for this thing. It just happened to be. Originally, this box here, forget this box here I made back in, oh gosh, maybe 2003 or so. And it's just a PID, a low PID temperature controller. It's programmable. It can use any of the thermocouples and 100 ohm RTDs of platinum resistor temperature probes. I ended up with, they were going to throw these away where I worked in engineering. And the stuff sat on the shelf too long and would have to be sent out for calibration for us to do anything with it. It was just cheaper for them to write them off. And some of it ended up in the dumpster land, and some of it ended up, and it was legit, they take what you want. And so I got about a dozen of these things. And it's perfect fit for this temperature controller. These are controlled temperature. There's a RTD in the tip somewhere, buried in there. Apparently pretty close to the heater in these. And it's 100 ohm RTD in there, very precise. And they last a long time. Usually what gives up the ghost in these is the heater itself. And that's if you abuse it. Overcrank the temperature and just let it sit and burn, and you'll waste it. But anyway, enough about the iron for now. As I said, this box originally was meant to just be a temperature controller for whenever I needed one. I do a lot of stuff where I do need to precisely control the temperature. Various projects I do, experiments and things. And originally on the back of it, there was a power entry module there, fused. And I just had this barrier strip and labeled the goes intos and goes outas, so I could hook. It's got two outputs and one input. Just put a temperature probe on it, and I use it to control whatever, heating, cooling, or both at the same time. And so that's what this started out as, and I'd used it for different things with great success. I say this is fully programmable, so it fits any of your temperature measurement needs. I've programmed it to limit its range of setting. I set it so I keep it in degrees Fahrenheit, what I'm most familiar with. But I set it so the lowest you can set it is 600. It's just about 600F. It's just about the point where solder begins to melt a little bit. and it'll let it go up to 900. Rarely do I get it up to 900. There are occasions when it will need to be, but that very briefly. 1,000 degrees is a bit much to ask for anything like this. This, by the way, is a 48 watt iron. I've seen some solder pullers, they're like 90 watts. I mean, where in the hell is all that heat going? It's not going into the tip because it would be red hot. I don't understand what they're talking about 90 watts. But 50 watts is pretty good for this small of an area to concentrate the heat there. That other design is just inefficient or something. Matter of fact, I've got an abomination over there I'll pull out later and tell you what I don't like about it. This here on the side is basically what I was working on yesterday to turn this into a controller for this iron. This basically connects to, you can see the cable run in here, and inside of here there's a dropping resistor, a solid state relay, a couple of LEDs and a switch. The dropping resistor is there. It's a power resistor, 1.5 ohm. This iron wants to run on 21 volts AC. The transformer in here is 24 volts AC. It would probably have worked just fine, but I'm a stickler for certain details. It says 21 volts AC, it gets 21 volts AC. It just happened that I had a 50 watt Deo power resistor that is 1.5 ohm, and I dropped it. It's exactly 21 volts AC under load, so that worked out great. And a solid state relay, little thing in there. This basically puts out logic levels, trips the relay. It's a solid state, it's basically a triac in there that switches currents into the heater. Right? So that's basically what it is. It's got the set point. It remembers it. Once you set the set point, turn the power off, turn it back on, it'll go back to that set point unless you change it. Yeah, which is convenient. It displays the actual temperature. The readout displays the process temperature. And if you want to see the set point or change it, you just push this one. And I've seen some controllers that have both. Well, yeah, I don't see the point in having the set point constantly displayed so much. This one you can program it so that it oscillates between the two, but that can be a little bit confusing. So we just display the temperature of the actual process, and that's it. These two LED indicators, one is red, one is blue. The red one comes on when it's heating, the power's on, and that one goes off, the red one goes off, and the blue one comes on when it's got up to the set point. And there's no cooling other than just convection, or if you're actually pulling solder through, heat dissipating into your work piece, and the air going in, will tend to cool the tip. It'll cycle on the heat, keep that on longer. This switch disconnects this box from the back terminals so that I can put another something else on here and just disable the iron functions. The LEDs will still indicate what the two outputs are doing, but I could use it if in a pinch, if I wanted to do some other process control with this, I can still do that. Right now the iron's hardwired to this strip here. You can see strain leaf. I just cut the connector off. I don't like those connectors. I'm going to get something much better and put that in here. I've got another one of these boxes. I may rearrange things so I can have it, the connector conveniently located here or something. No big deal. We'll fix that. But another problem with some of these solder pulling irons, they take too long to heat. Let's see. Now setting a timer here. Lab timer. Let's see, right now, temperatures, so it looks like I can see 80 something in here. So it'll show that, and I'm going to time how long it takes to get from 80 whatever degrees to 750 degrees. Should take, by my last check, 90 seconds once this is turned on. By the by, if I turn this off, that removes the heater and the temperature probe from the circuit. If I turn this on, it shows an error because there's no RTD connected, is what error 4 is. So connect the iron bits to it and time how long it takes to get up to temperature. And then you'll be able to see it when the blue light comes up. Okay, see we're getting heat. And it doesn't take very long. And while we're doing that, let's see, where to go next with it. This is nothing magic here. Yeah, I designed it, but it's ready-made controller put in a box with a transformer to power it, and this to convert the signals to something I can use here. The switch and the power entry module, that's pretty much all there is in that box. So our set point is 750. It's getting there. See, it's taking a little longer. Oh, that's right. I was timing it to 700. That's why. Okay, so a minute and a half. 90 seconds. All right, now I'm hoping this shows up. About to. When you watch this display, the deviation from the set point is about both plus and minus about 8 or 9 degrees. That's real tight control. It doesn't need to be that tight. But there it is. You said it, it goes there, plus or minus 8 or 9 degrees. Now, of course, we're not drawing any heat or anything from it, so it's spending a lot of time idling. And then heat comes on, heats up, it's losing it from convection. Once that comes on, of course, once you start working, drawing air through that, and it'll spend more time red because it's spending more time heating. Another thing I like about these pace irons is the variety of tips that come with, or that you can get with them. They're interchangeable. I can put regular tips in that and just use it as a soldering iron. But they all kinds of these tips. This one here, it's so, I forget the exact dimensions, but it's like 2 millimeters or some silliness like that. You could barely put a straight pin through that hole. Where this one, you could put, OD of this is, I don't know, maybe about 1/8 an inch. This is very thin walled. But you put that deep into the heater, let a little bit of it stick up, you get plenty of heat transfer, so you can really get this over big pins on connectors and things like that. This is actually the biggest you can get. This iron actually has an adapter in it to accept these smaller bits. You take that adapter out, and there's big honking bits, tips you can put in there. De-solder stuff that's like a quarter of an inch in diameter or thereabouts. I got this iron and two others at a really good price, brand new, and some extras. Long story how I got them, but the price was right, and the guy had a wide assortment of tips. Every one of the small diameter ones that they make, except for the curved ones. There are none of those in here for some reason. But I'm going to order up some other stuff anyway, so I do that. I'll get some of those large tips, a bunch of the cotton filters that go into the solder chamber, spare glass chambers, spare heater elements, all included, everything. Spare set screws. So this is, for me, a lifetime supply of this stuff. These bits, if you treat them well, don't let them run when you're not using them, they go a long time. And with that iron, also got this tweezer. It's missing a set screw, but I got a bag of them. Never been plugged in, never been heated. Brand new. I don't have any bits or tips for this, so I got to order some. And this is regular pencil iron. Now, I can take this tip out and put it in that and use it as a soldering iron. It's a little unwieldy. This is nice and thin. So I want to put a connector on there so I can swap out these as I need to. And so that's for the irons. That's the controller I'll put together. But real interesting part about this is the pump. I've used a lot of different methods. Some work fairly well, while others are just undoable. I will use, it depends on the work I'm doing. If I'm doing point-to-point work, I'm not going to use this in any way for point-to-point work. I do work on vacuum tube and stuff, and it's point-to-point. That's just useless. For that, I use a solder bolt. The spring-loaded sort of a syringe pops out. Those work great for that. But those don't work so great for circuit boards, especially multi-layered boards. You can, with enough finagling to get it to work, maybe add some bismuth wire to it to lower the melt point of the solder you're trying to get out of there. But one of the biggest problems with all of them is the way they do the vacuum. Primarily, it comes on too slowly. It builds up. It's not a sudden vacuum. It ramps up too slowly. The solder pult doesn't really suffer from that. When you push that button and release that plunger, it snaps. And so the vacuum is pretty much instantaneous, and is very steep increase in the, or I guess you say decrease in the pressure in that nozzle is abrupt with those spring-loaded things. Some of those don't work. The smaller ones, there's just not enough volume being displaced, not enough spring to move it fast enough. Smaller, cute aluminum ones, I find those useless. If you got a single-sided board, yeah, just about anything will work. Solder braid, I use that. primarily for mopping up after doing surface mount work. You get solder on a pad after removing a component. I'll use some solder wick on that to clean the bumpy solder off so I can stick a new component on a nice flat surface, with the pads on the board. So, so anyway, one of the faults, it's a big one, is the way a lot of them build up the vacuum. Even the bulbs do a pretty good job. Not as good as a solder bolt, but they can work. I've seen ones and used them that have something like this with a bulb on it. This thing is for multi-layer boards about as useful as tits on a board. It just doesn't have the moxie for it. This has got some age on it. The first desoldering, the vacuum desoldering pump, using a pump, the desoldering tool that I ever owned, where I worked at the time. This was back in the 80s. Where I worked at the time, that's when I was introduced to the pace irons, and that one plugged directly into the wall outlet and was not heat controlled. It worked great, but the thing ran like 900 degrees all the time. This thing is it's temperature controlled. It's a WTCP type. If you're familiar with Weller soldering irons, this typical thing. And so the temperature of the tip is determined by the tip. It's a magnetic heat thing in here that switches on, and it's just an on-off control. Oh, by the way, this is set to on-off. It is a PID controller. I am not using a PID. It's simple on-off. By the way, I fiddled with the PID, but it takes it longer to get the temperature because of the way the PID works. It's trying not to overshoot. I don't care about overshoot. And so anyway, I'll keep it as a conversation piece. Very limited in the number of the sizes of the tips you could get for it. You do 2 or 3 joints and it cools this down too much. There's a lot of mass that has to heat up. All of this. So, and this is what is this? This is a 48 watt iron, and it's losing a lot of heat through here. So it's trying to keep this hot enough. You can see I've used this a lot over the years. This is barely darkened or blued from heat. It's just, it never really gets as hot as it won't stay hot. If once you use it, pulling air through it, wicking the heat out into your workpiece, it's no good. So the pump. I'm gonna rearrange the camera to focus on it. Now, rather than stop it, what the heck? I will have to give some perspective of size. Back this out. Oh, it won't let you. Dang it. This camera's funky. Sometimes it just doesn't work great. Anyway, that's the pump and valves and the gauges and stuff. I'll get up close to that, or maybe too close already. Sorry about this horrible camera work here. Yeah, I am going to stop this because now I need to refocus. Yeah, that's better. Yeah, if you see it. This is the pump. Obviously rather large and kind of noisy. And the other thing too is this runs continuously. It doesn't only come on when you're sucking the sock. And there's a reason for that, which we'll get into. It's one of the faults that those have. It's got a gauge. I can read out the pressure. This pump will pull down to 25 inches of mercury, which is about 600 millimeters, or 600 some millimeters of mercury, which is pretty much what you need for some of this stuff. If it gets lower than 15 inches, you're getting into this, you're in some trouble with it. And I've measured some of these things, and they barely make it to 15, and it just don't work right. And because the motor starts when you call for vacuum, the vacuum ramps up rather than snapping on. This snaps on. This is just uses a reservoir. So this is pumped down. This gauge is attached to it. And see, I'm going into the pump. And out here's going to a solenoid valve. And with a filter there, and just going up to the iron. And this is actually a water valve for an appliance like a washing machine or an ice maker in your fridge. Just solenoid valve. I picked this particular one because it had a high flow rate to it, which it's bigger aperture. It lets more air more quickly pass through, of course. That's what you want. It's actually not the best choice because the aperture is kind of small. I have another valve I'm probably going to replace this with. It's an industrial strength valve. This board runs on 120 volts. This coil, which this system here runs on 12 volts. So I use a little mechanical relay to switch in the 120 to energize that solenoid. I could get rid of that altogether because the solenoid I have, this industrial one, is a 12 volt coil, AC coil. So that's probably what I'll do. This I buy 1/8 horsepower. I bought that brand new from a guy where I used to work. This guy, he rolls into the shop one day, and he's asking if we're interested in buying pumps. And it just happens that we were thinking about making a central vacuum system to feed all of the benches in the lab, and then we just tap into the tube. And the pump would be remotely located, so you don't have to hear it. It was on a switch, and once you pump down to the right vacuum, it would cut the pump off. And they worked great there. But while the guy was there, I bought one too. And they were dirt cheap. I think I paid, it was something like $20 for this. New in the box. And this old fella, he had all kind of stuff, but and more of these. I don't know what the thing's made by Gould. I don't know what that retailed for, but I won $20, I'll tell you that. This over here, it switches on the pump. This is a switched dimmer, and it's tied in with light. That's just this outlet here is connected to this control. And so I've got a 120 volt iron here. The first iron I used for this, it was like that Weller I showed you. Well, it was a Weller, but it was a 120 volt heater. So I plugged that into there. And this, I didn't use this as a temperature control. I used it as turn it all the way down. It was just simmer, keep it warm, but not enough to really do any soldering. But when you needed it, I just crank this up and go full bore. And I forget the wattage of this thing, and it doesn't matter. So anyway, keep it on simmer. Not quite hot enough to solder. This is just a connection to the foot switch right there, which that's what triggers the pump. Right now, it's not on, or that's what opens the solenoid valve. I'm sorry, you're doing that. That buzzing is this. And so this iron, the pace has a button on it. I prefer the foot switch because I always hitting this button, just trying to get in the right position when I didn't want to. The foot switch is much more convenient. Sometimes you get all set to go and you realize the button's on the wrong side. It's just a pain in the butt. So this button doesn't do anything. The foot switch does. I'm going to turn this motor on for a second. You get an idea the kind of noise it makes. It's not horrible. And it's pulling down to 24 inches as usual. The rotary vane pump. And it immediately drops the differential because it's being a rotary vane pump. When this stops, there's nothing to keep the vacuum from, air going in right through the pump. These only seal when they're spinning. There's no valves in this, per se. The vanes are the valves that spin. I don't know if you know how rotary vanes work, but look it up. Yeah, they're pretty neat. The outlet down here is, I made a muffler. It's just a PVC tube with end caps on it, and there's foam in there. Some holes punched in the end cap. There's a muffler. There's a valve I can close to shut this off. Or, close this valve. The muffler's isolated, it's blocked. And I can open this up and use it as a compressor. This will go up about 20 psi gauge or so, last I checked. And occasionally I use some of these air compressor sources. Somewhere 20 psi or below, that works for that. Otherwise this stays closed. The muffler is pretty effective. I'll show. I'll turn it on and then open this valve and you can hear the difference. So nobody wants to listen to that. Now, how much pressure drops, it's going to depend on what tip you have in it, obviously, because of the bore size. Smaller, it's going to drop less. It's also an indication if things don't seem like they're going right, maybe it's time to change the filter, dump the solder out of it. This, again, is to serve no purpose. It's just a reservoir. It was for something else. I don't remember. In fact, the guy that sold me the pump sold me this. I think I paid $2 for it, and it served some specific purpose, but it was perfect for this application as a reservoir. So the way this setup is this pump runs continuously. This is pumped down always when you're using it, and when that valve opens, bang, you got vacuum. It doesn't ramp up, it snaps up. 2 snaps up. So I don't really much more to go in, but it's huge. What I don't like about it, it's heavy and it takes up a lot of room. You can't even put this up on your bench, so it's underfoot. That I don't like about it, but what I do like about it is how well it works. It never gives me any grief. It does what it's supposed to do well. I don't think I've ever seen a bigger de-soldering station pump. If you find one, leave a comment. I'd love to see it. This I built in the 80s. This I built, this box in the 2003 or so, and this addition I put on for the iron interface was built yesterday, conceived, drawn out and built yesterday. It's not much to it. I don't know if I'm gonna, I've been prattling on long enough anyhow, demonstrate desoldering with this thing. Yeah, why not? Let's do it anyway. It's because it's funnier that way. And I'll put this something about like that. Actually, that's not going to do any good. You know, lighting in here is not really good for this. Okay. It's not going to be in focus though. All right, I'm gonna snip this and be right back. Okay. Yeah, better focus. And let's see, some scrap boards here. And it's already up to temperature. Part of the reason for this, I do repair work. I'm retired, sort of semi-retired, and I do a lot of repair work. Some of it's surface mount. That's why I really need to get the parts for those tweezers. I manage without that, but it's tricky, and I'd rather not have to be dealing with tricky. This is all through-hole stuff. Already moved a bunch. This came out of a logic analyzer, and has some really good goodies in it, many of which I've removed. All these precision resistors, I take those, keep them. Interesting components that I know I don't have, I'll snatch them out too. Let's see, this is a, what's that, 16 pin dip. Let's see, we're set to 750. Yeah, get my foot switch ready. And get this so I can just kind of lean my foot on it without tripping it. I have to consciously step down. So I'm not going to talk while this is pumping. You probably hear me, but and commence to pull out one of these 16 pinners, this one right there. Okay, yeah, falls right out, just like that. And it handles, I don't know if you can see, let me look. Oh yeah, you can't see the display on there. But anyway, it changes very little doing this light work. This is a 3-layer board. 2 on the outside and 1 in well, actually it's 4-layer. It's got a ground and a B plus plane in it. Interesting. So, 4-layer board. This will handle like 16-layer boards. I'm not kidding. Especially if you can get the temperature up. So, I do a lot of scrap work, scrapping as well. So I use this. Let me turn it off. I use this obviously for repair work, but I do a lot of recycle scrapping, everything, and I'll cherry pick. Look, it's got all kind of goodies on it. Most of which I have anyway, but for something I don't, for some, specific kind of components, unusual ones, ones I have a series of. I don't have that particular number. I'll pull them out. This has got a lot of ECL logic on it. They're all ceramic. These are presumably in memories of some sort, precision resistors. So there's some stuff I'm going to save, and then this will go to further down the line to get the gold. I don't do that. I used to, but it's not worth my time. You know, whatever becomes of it after that, I don't know. I don't really care. I get the goodies. And all the aluminum and copper and the items that these come from. A lot of test gear, televisions, you know, flat screen TVs. Those plasma TVs, man, they got all kind of goodies in them. Oh, bunches of heat sinks, aluminum heat sinks. These lovely high voltage, high compliance capacitors in them. Oh, look. I very rarely have to buy a part. Put it to you that way. I'm a hoarder for parts, sort of. And I see some good coin for the scrap metals from doing it. That's why I do it. So I'm getting down to getting rid of the metals go quick. Getting rid of these boards takes a little long. That's why I had to get this thing up and ready to go. In my downtimes, I sit out here and I do it in the house, but it's a little noisy. And it's here. It's not gonna take me too long to get through this box of boards I got stashed over there behind me. So anyway, I don't know. It may not be the biggest, baddest desoldering station in the world. My money has it is. Yeah, it's not. Find it. Show me.